Hello everyone. In today's class we are going to do addition reactions in alkenes. Addition in alkenes. Before doing anything, we should be clear about the structure of alkenes. If we talk about the structure of alkene, say we are starting with the simplest molecule, ethene or ethylene. The formula is C2H4. Here both the carbon atoms are undergoing sp2 hybridization. So the structure will be something like this. Trigonal planar, 3 hybrid orbitals are formed, all are half filled like this. Same is for the other carbon also. Other carbon is also undergoing sp3 hybridization. 3 hybrid orbitals will be formed. Trigonal planar arrangement. They are also half filled. Now out of these 3 orbitals, 2 will overlap with hydrogen in this way. Hydrogen like this. Hydrogen, one is half filled orbital like this. So here we can see all these are the sigma bonds formed. This is one sigma bond formed, this is another sigma bond, one more, one more, one more. So all these are the sigma bonds formed. Now what about that there is an unhybridized orbital also, because sp2 is the type of hybridization. So one unhybridized orbital is also left with each of these carbon. So that is how these unhybridized p orbitals, they will undergo sideways overlapping to form the pi bond. So that is how, if we see the structure of carbon, how the structure of ethene is there. It is C double bond C, H, 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 H. So this is a sigma bond, sigma bond, sigma bond, sigma bond, sigma bond, and there is one pi bond which is obtained by the sideways overlapping. Now because this sideways overlapping is very less overlapping, extent of overlapping is very less, that is why this pi bond is a weak bond which can easily be broken, and when this bond will be broken, a pair of electron will be free. Pi pair of electron is, that is why, loosely bound and is easily available for the incoming electrophile. Loosely bound and easily available for the incoming electrophile. That is why alkenes have tendency to undergo electrophilic addition reaction because of this reason, because the pi pair of electron is acting as a source of electron for the incoming electrophile. That is why. Now we are moving to what type of additions, or you can say what are the examples of this electrophilic addition. Now addition may be of the symmetrical reagent, addition of symmetrical reagent. Now what do we mean by symmetrical reagent? The reagent which contain the similar parts, like H2, both are H and H atoms, Cl2, Br2, all these are what? These are symmetrical reagent. Or it may be unsymmetrical reagent also. Now what are unsymmetrical reagent? When there are two different parts in the reagent, one is negative, other is positive. Like if we talk about HBr, positive, negative. If we talk about HCl, positive, negative. If we talk about water, it is positive, negative. If we talk about H2SO4, it is H positive, HSO4 negative. So what I am trying to say, that we may add the symmetrical reagent or it may be the addition of unsymmetrical reagent. Now let's do the examples. We are starting with the addition of the symmetrical reagent first of all. Now say we have ethene, CH2 double bond CH2. When we add hydrogen, addition of hydrogen, this reaction is called as hydrogenation. Addition of hydrogen is called as hydrogenation reaction. So we are starting with hydrogenation, and hydrogenation of alkene will always take place either in presence of nickel, platinum or palladium. Now out of this H2, one H on this side of double bond, one H on the other side of the double bond. So that is how the addition will take place. So it will become CH3, CH3, and the double bond will be converted to a single bond. Say for example, we have this molecule CH3, CH double bond CH2, and say if we add hydrogen to it, then again in presence of nickel, platinum or palladium, the addition will take place and we will get CH3, CH2, single bond CH3, H on this side, H on this side. So that is how propane is obtained. So this was propene, propene converted to propane, or you can say ethene converted to ethane. So that is how the addition of the symmetrical reagent, that is hydrogen, is taking place. Now the next we are doing, say we are talking about halogenation. Halogenation, it may be chlorination, it may be bromination, it may be iodination, etc., anything, right? Now let's take the example of bromination, because this bromination reaction is also used as one of the distinguishing tests for the saturated and unsaturated compounds. So how is the reaction? Say we have CH2 double bond CH2, and if we add bromine to it in presence of CCl4, then one Br on this side, one Br on the other side, and what are we getting? We are getting CH2Br, CH2Br, and the molecule obtained here is 1,2-dibromoethane. 1,2-dibromoethane addition has happened here. Now let's take another example. Say we have propene CH3CH double bond CH2, it is propene, and if we add bromine to it, then too the addition reaction will take place, and the reaction will be like this: CH3CH, one Br on one side of the double bond, another Br on the other side of the double bond, and double bond converted to single bond. So that is how we are getting another compound, that is 1,2-dibromopropane, a vicinal dihalide we got. Now there is one thing special about this reaction, about bromination. What it is, this bromination is used as a distinguishing test, for the saturated and unsaturated compound. Saturated and unsaturated compounds. How is it? How can we use it? Like if we talk about the saturated compound where the carbon-carbon single bond is there. Like say if we are talking about ethane. Now in ethane, if we add bromine, then nothing will happen to bromine. I mean bromine will not be added like this. So we will say no reaction under these conditions. No reaction under these conditions. So bromine is what color of liquid it is? It is reddish brown, or you can say reddish orange liquid. So this reddish orange color will persist as it is because nothing happened with bromine. Bromine is as it is. So the reddish orange color will be retained. No change in the color. While if we talk about when we add the same in ethene, then bromine will undergo addition. You can see if we add the same in bromine, then you can see that we are getting CH2Br here, single bond CH2Br here. So there is no more bromine further. So that is why whatever was the reddish orange color, now the color will be discharged. So reddish orange color will be discharged because of the addition reaction taking place. This is how it can be used to distinguish between saturated and unsaturated compound, or you can say it can be used to distinguish between the ethane or ethene, or maybe ethane or ethyne, the saturated and unsaturated compounds basically. So this is all about the bromine test. Then we are moving to, in place of adding bromine, we could have done chlorine also, but that cannot be the specified test. As such, there is no observable change we will be having. So that is why this is used as a distinguishing test. Now moving to the next, that is addition of unsymmetrical reagent. Addition of unsymmetrical reagent. When we add unsymmetrical reagent, like say for example we are adding HCl or HBr, etc. So addition of hydrogen halides we are doing first of all. Addition of hydrogen halide, HCl or HBr or HI. Addition of hydrogen halides we are doing. Hydrogen halides. Now here, say if the alkene is symmetrical, say it is CH2 double bond CH2, and if we add HBr to it, the unsymmetrical reagent to it, this is the negative part, this is the positive part. So whether negative go on the left side or the positive go on the left side, whatever is there, we get the same type of compound. What does it mean? Like say for example, H is going on the right side. So we will get CH3 and it will become a single bond, and CH2Br. What is the name of this product? The product is what? That is bromoethane. Or the other possibility was that H will go on the left side. Then it will become CH3, CH2Br. This is again bromoethane. So what I am trying to say, whether it is symmetrical reagent or unsymmetrical reagent, if it is a symmetrical alkene, if the alkene is symmetrical, what is symmetrical alkene? When both the groups on both sides of the double bond are same. When it is a symmetrical alkene and we add some unsymmetrical reagent, it won't make any difference, we'll get the same kind of product. But what if the alkene is also unsymmetrical? Say for example, we have CH3 single bond CH double bond CH2. And this is the unsymmetrical alkene. We can see on one side we have CH2 group, on the other side we have this group, on the other side we have this group. So the two group on both sides of the double bond are not same, they are different. So this kind of alkene is called as unsymmetrical alkene. So to this kind of unsymmetrical alkene, if we add an unsymmetrical reagent, then there are two possibilities to get the product. What are these? Say for example, the negative part is going to this carbon. So what will be the product here? It will be CH3, CH. If negative is going to this carbon, then H will come to this. So it will become CH2, double bonds converted to single bond, and CH2Br. So we will get 1 bromopropane as the product. But say if reverse of this happens, reverse of this means say Br goes to this carbon, then what will be the compound formed? The product obtained will be CH3CHBr single bond CH3. The product will be 2 bromopropane. So both the possibilities are there. Now which one of the two will be the actual product, or which of the two will be the major product? How do we decide? This is decided, or this is followed by a rule. What is that rule called as? That is Markonikov's rule. Markonikov's rule. What this Markonikov's rule state, according to this rule, the negative, whenever the reaction take place between an unsymmetrical reagent and an unsymmetrical alkene, the negative part of the addendum goes to that carbon of the double bond which carries lesser number of hydrogen. So say this is the unsymmetrical alkene and this is the unsymmetrical reagent added. So according to Markonikov's rule, negative part of the addendum, addendum means the adding molecule, this is the negative part of the addendum, it will go to that carbon of the double bond which carry lesser number of hydrogen. So this carbon is carrying lesser number of hydrogen, so this will go to this. So that is why the product formed should be what? The product formed should be CH3 CHBr single bond CH3. So the product will be 2 bromopropane. So that is how the addition of the unsymmetrical reagent take place. Thank you.